Hi, this is Mike Linn, your corporate metrologist here at IndySoft, and today I'm going to talk a little bit about a new feature that we added in version 14.1. Now, most of you are used to using our test point flyout over here that's kind of a global type setting for all of your test points. As you create test points, it uses this tolerance value, the formula that comes from your global settings, the default unit of measure, and resolution. And as you create the test points, you can see that it calculates these tolerances based on this information. So 2, 3, 4, 5. So regardless of what value we're putting in here, it calculates with this. Now, previously, we've also had the tolerance calculator, which allows you on a per test point basis. So let's just go back to the 3 here. And let's say we want to do something a little different. We can say tolerance of 0.03, and we'll give it a tolerance type of asymmetrical. So it has, let's say, 2 different tolerances. So we'll give it a minus 0.03 and a 0 on the plus side. And we say, okay, so now it's calculated this. Now, if we go back and change this value, you'll notice it picked up from over here. So the values that are used in here do not save with the test point. So this is a one-time calculation. As you create the test points, this is what gets used. So what we introduced in 14.1 was our advanced tolerance calculator. And it's the icon that's right next to the previous one. If you click on that, it opens up a window. Now, our tolerance types are limited to bilateral, asymmetric, plus or minus. There's no formula involved here because it uses all of this as one calculation. It's always the same calculation all of the time. So I can have a value, let's say I want 1% of the reading. And you'll notice because I'm on line 3 and line 3 says 4, it brought in that reading. So it's going to calculate that percent of reading here. And you'll notice this is not editable because it's tied back to that test point that you're on. Now let's say I've got a percent of range component to this specification here. So let's say it's a 0.02 ppm of the range, and let's say our range is 100. So it's going to calculate that value. Now, typically you're not going to have an of range and of span. Maybe you do, maybe you don't, doesn't matter because you can fill in any of these or none of these. It's still going to calculate using what the information you enter in. So let's say our span maybe is say from minus 15 up to 30. Maybe it's a compound pressure gauge or something like that. And then we have the same situation here. We've got a factor value, maybe 0.02. And again, we've got percent, ppm, ppb, 10 to the 6th, 10 to the 9th. That's what those stand for. And then the span is going to calculate using the information you put here. Or if you don't put in a complete, the max and min, it's going to use whatever value you put there. So it's calculating that part there. You also have maybe a fixed offset, also known as a floor value. In a lot of the manuals, you'll see it called floor. Maybe we're going to say add 0.001, right? So it calculates everything together and gives you a total error value for this tolerance here. All right, so you can see it's calculated that. Now, if I go a different layout here, we go to demo 2, you'll see that this information got stored in these fields. So no matter what I do now, if I change this to a different value, you're going to see it's going to recalculate using this information that gets stored with the test point. So that's the difference between the old calculator and the flyout here, is that this information here doesn't get stored with the test points, but with the new advanced test points, it does. It stores that data there. You'll also notice it's checked this box called advanced tolerance. So that's how it knows that, hey, this has a special setup so that this information here is used in the tolerance calculations. Now, you'll notice again, now if I open this up, it pulls in that previous data. So it reads in what it had at that test point value. Now, one thing you can also do is, let's say I want to add a new group here, new set of measurements, right? Let's say this is DC volts, and I want to do 1, 2, 3, 4, 5, 6, right? Oops, one. I didn't save it. No, I see what I've got. There we go. 2, 3, 4, 5, 6. All right. So I can now go in and turn on my multi-select, and I can select using the shift control. I can select all of those. I can right click, or not right click, click that button. There we go. So now you see it's cleared out. I don't have anything in there. I can say apply to all cal test points. I can set up my values however I want. Let's say 0.01 or 0.01, a 1% of reading, and maybe 5 ppm of range from 0 to 500, right? So it's going to give me this tolerance here for that 3 reading that I was on when I right clicked. But if I hit OK, you'll see that it applied it to all of those test points, and each one of them is calculated based on the information at each one, because I'm using the range is the same, but the individual readings were different, so I'm getting different tolerances. Now you'll also notice, right click, I keep not right click, but if I bring this back up again, I can apply to the use tolerance. So if you're using the new and used tolerances, particularly for mass or something like that, where you have separate tolerances, you can apply it to both. And you'll see it apply the tolerances to the use tolerance there. So this is something that'll help you build out your test points faster. It maintains that information. So even in the event, if your techs go into the event and you allow them to modify the data, let's say they have to change the nominal or something like that, when they enter the nominal, it will recalculate based on the tolerance setups that you created here. So hopefully this will help you out and give you a lot better control over your test points and help you enter them faster.